Hello, my name is Mike Fry, and I'm a senior product design engineer at PSG. The purpose of this short video is to discuss a feature of Blackmer's new MAGNES pump family. The containment shell is a very exciting feature of this MAGNES series, and it offers some key design benefits that we'll talk about. The MAGNES pump family targets flow rates between 75 to 520 gallons per minute. The pump can be configured with ductile iron or stainless steel materials. The pump is capable of running thin fluids at differential pressures up to 200 psi. One of the huge advantages of the MAGNES pump is the ability to dry run. This can be encountered during expected cases like self-priming or line stripping. It can also occur in unexpected cases due to system upset conditions or operator error. One of the big reasons the MAGNES pumps are able to handle dry run is the containment shell design. Before I can describe the advantages of the MAGNES containment shell, I think it's important to describe the physics background. When a magnetic field passes over a conductive material, a current is generated. This is called an eddy current. Eddy currents come into play with mag drive pumps because typically magnetic couplings are moving around a stationary containment shell. If this shell is conductive, eddy currents are generated. These currents result in torque loss and heat generation. The pump is then required to remove the heat by flushing the coupling with pump fluid. Also, the coupling typically has to be oversized to compensate for the torque loss from the eddy currents. The MAGNES pump is able to transfer up to 1,000 foot-pounds with no eddy current loss due to the containment shell design. Containment shells have some pretty difficult design requirements. They must be relatively thin, in addition to being rigid and strong. The coupling halves need to be as close as possible to each other to maintain the magnetic strength. The magnetic field strength decreases dramatically as the distance increases. The shell is also required to be strong. It is a pressure containing element that must withstand max anticipated working pressure of the pump. It also can't deform and make contact with the moving coupling. Many designs utilize exotic materials like Hastelloy that can be formed into thin-walled strong parts and have somewhat lower conductivity. These parts are typically expensive and still generate some eddy currents. Other designs utilize injection molded plastics. These designs avoid eddy currents, but injection molding has some drawbacks. The shell typically has to be thicker, which means the coupling must be oversized. The plastic deflecting under load can also be a concern. This means that the air gap between the coupling must be further increased and the coupling must be further oversized to compensate. The MAGNES shell utilizes a proprietary molding process that is able to increase the strength in the direction that it's required. This means that the MAGNES shell is able to have comparable strength to metallic shells in a non-conductive material. This results in an extremely reliable pump that is able to withstand dry running and still keep running. To demonstrate the pump's dry run performance, MI3 pump was run dry at max speed for 10 minutes. This is a time-lapse video that shows the dry run at 16 times normal speed. The surface temperature near the magnetic coupling was recorded and displayed on the screen above. It can be seen that the surface temperature only rises about 7 degrees Fahrenheit. This can be attributed to friction with the vanes, shaft, and bushings. No heat was being generated by the coupling. The end of the video is at real-time speed and shows the end of the test. The pump is able to withstand 10 minutes of dry run with no impact to performance and minimal temperature increase. In summary, the MAGNES pump family combines Blackmer's world-class vane pump technology with a reliable leak-free design. The negative effects of eddy currents are eliminated with MAGNES's proprietary containment shell design. The dry run performance of MAGNES pumps has been proven with extreme testing. If you want a reliable, leak-free pump that eliminates costly, unplanned downtime, consider a MAGNES.
PSG, where innovation flows.